Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we look at completing the square. So you're probably thinking to yourself, why do we need yet another method of solving quadratics? Well, let's say we wanted to solve x squared minus 2x minus 1 is equal to 0. So if we try and solve this in the usual way, we would try and find two numbers that multiply to -1 and add to -2. You probably can't, off the top of your head, figure out what those two numbers are. But there actually are two numbers that multiply to -1 and add to -2. It turns out that those two numbers are -1 minus root 2 and -1 plus root 2. How could anyone think of this off the top of their head? I really can't expect you to do that. So what we need another method that will allow us to solve quadratic equations where we have weird numbers like this. And that's what completing the square does. It's really good because not only will it come up with weird solutions like this, which are sometimes the solution to quadratics, but it will also enable you to determine whether or not there actually are solutions, because sometimes there are no solutions. So the idea here is we want to write our equation so it looks like a perfect square. Then we can sort of treat the thing like a linear equation. So let's take our equation, x squared minus 2x minus 1 is equal to 0. So I want to try and write this as like x minus something squared or x plus something squared. So can I think of something like this that will get me close to this? So it turns out all you have to do is half the coefficient of x, half of b. So if I halve -2, I get -1. Now note, if I expand x minus 1 squared, I get x squared minus 2x plus 1. So it looks very similar to what I have here. But I can't just change this into a plus 1 because that would be a different expression. What I can do is I can write this as x squared minus 2x minus 1, like it is, and add 1, and then take 1 away. And that will ensure that this is the same as the previous expression, and that means it will have the same solutions. But what's in red is a perfect square I can write like this. And of course, -1 is just -2. So now, what I have is a perfect square minus something is equal to 0. Now, by doing this, what I can actually do is treat this like a linear equation. The reason I can treat this like a linear equation is the x is only in one spot, whereas here it was in two spots. So remember, normally I don't want to do this, but when I'm completing the square, I do want to do it. I do want to treat this like a linear equation. So what I'm going to do is I'm going to add 2 to both sides, and I get x minus 1 squared is equal to +2. So now I can square root both sides. I can take the square root of this and the square root of this, and I will get x minus 1, because squaring and square root undo each other. X minus 1 is equal to root 2. To get x by itself, I just add 1 to both sides, and the answer I get is 1 plus root 2. But hang on a minute. If I square root 2, I've also got to account for the negative solution. So the other possibility is that x minus 1 is equal to negative root 2. Because if I square negative root 2, I still get +2. So now I will add 1 to both sides again, and I will get 1 minus root 2. And they are the two solutions, 1 plus root 2 and 1 minus root 2. The same solutions I would have got up here. So if I went ahead and factorized this, I would have put x with the first thing, and then in the second bracket, I would have put x with the second thing. And of course, if that equals 0, either the first bracket equals 0, so I just change the sign of everything, or the second bracket equals 0. So then I just change the sign of everything again. And I get the exact same solutions. But completing the square, though it's a bit complicated, didn't require me to come up with these weird numbers off the top of my head. So let's look at some other examples. Please pause and copy this down if you need. So let's say I want to solve this equation, x squared minus 10x plus 7 equals 0. Once again, I have a quadratic trinomial, it's monic, but there's no way I can find off the top of my head two numbers that multiply to 7 and add to negative 10. That's going to be too hard to do. So what we're going to do is we're going to do completing the square. So remember, what we do is we want to halve the number in front of x. Now, if I write this as x minus 5 squared, remember that's x squared minus 10x plus 25. So what I want to do is I want to add 25 here, and then I want to take it away so I'm not actually changing the expression. So what that gives me is x minus 5 squared, which is all of this together, and then I'm left with 7 minus 25, which is minus 18, and you know how to do the rest. We add 18 to both sides, and now we square root each side. So I get x minus 5 equals square root of 18. So x would be 5 plus root 18. Or we have x minus 5 is the negative square root of 18. So adding 5 to both sides gives us 5 minus root 18. They are the two solutions. So there's no way we could come up off the top of our head with these two being the numbers that multiply to 7 and add to 10. There's no way we'd know that they would go in the brackets. So once again, please pause and copy down if you need. We'll go through one final example. Let's try this equation here. X squared minus 12x plus 50 is equal to 0. So once again, this is a quadratic trinomial. And if we tried to find two numbers that multiply to 50 and add to negative 12, we'd get nowhere. It turns out that this quadratic actually has no solutions, though you wouldn't know from looking at it. It's not at all obvious that there wouldn't be any solutions. But the good thing is that the completing the square method will allow us to see why there are no solutions. So let's go through the completing the square process. So what I want to do, if I halve this, I get negative 6. So negative 6 squared is 36. I want to add 36 here to make this a perfect square, and then I want to subtract it. So what you do is you half b and then square it, and then that's the number you need to add and then take away. So this part here, x squared minus 12x plus 36, that's actually equal to x minus 6 squared. So it's minus 6 because that's half of minus 12. So then I'm left with 50 minus 36, which is 14. So if you understand how I got to this step, you should see why there is no solution. If I try and solve it like I just did, I start by subtracting 14 from both sides. I get x minus 6 squared is equal to negative 14. You can't have something squared equaling a negative. If you try and square root both sides, you'll get an error. You put in square root of negative 14 on your calculator, you get an error. So because we have something squared equals a negative, there is no solution. So it turns out that if you actually wanted to factorize this, find two numbers that multiply to 50 and add to negative 12, there are no such numbers, not even complicated surds. But again, it wasn't obvious just looking at the equation. We went through the completing the square process and it showed us that there is no solution. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.